calls వస్తాయి calls వెళ్తాయి
Good afternoon, students. So last topic in the morning. Naveen is there? Naveen. Okay. Okay. How are you?
Fine, sir.
Fine. Okay. Right. Good. So now, in previous classes, we discussed about the types of polymerization. Types of polymerization are addition, condensation, co-polymerization. Next one is the plastics. Plastics are thermoplastics and thermoplastics.
Disturbance వస్తుంది sir.
Okay. Wait for 1 minute.
Sir.
Yes. Now any disturbance is coming? No.
Sorry.
No, sir.
Okay, right. So now in the module 3 last topic, that is biodegradable polymers. So previously we discussed about the types of polymerization, that is addition polymerization, condensation polymerization, co-polymerization. And next coming to next topic, that is plastics. Plastics are two types. That are thermoplastics and thermosetting. Plastics, thermoplastics and thermosetting plastics. Next one is the difference between the thermoplastics and thermosetics are the very important. And next one is compounding of plastics. Compounding of plastics means in the molding process we are adding some additives, then they will show their properties. That compounding of plastics are resins, plastages, fillers, and pigments, antioxidants, fire retardants, catalysts, etc. These all are the compounding of plastics. Next topic, very important one, that is preparation properties and applications of PVC, Teflon, Bakelite and nylon 66. These are the very important for you. Any one question. So in this preparation properties applications, so sure 100% they'll ask question. They'll ask question from this one. From this 4, they'll ask any two: PVC, Teflon, Bakelite, and nylon 66 for 7 marks question. Now last topic in the module 3, module half of the model, that is biodegradable polymers. So what is a biodegradable polymer? How they are classified, and what are the applications, properties about the biodegradable polymer? Synthetic biodegradable polymers we are discussing. Okay. One by one, we'll discuss one by one. Biodegradable polymers. This one is not there in our syllabus now. After completion of CA1. So now, what are the biodegradable polymers? Biodegradable polymers means the polymers which are easily degrade or easily decomposition takes place, disintegration takes place. That type of polymers are called as biodegradable polymer. When and the action of bacteria and fungi, algae, etc. reaction takes place, the disposal takes place. So simply disturbance ఇక్కడ ఏం లేదే మరి. Biodegradable polymer means the polymers which are easily degrade or easily disintegration or easily deformation takes place when the action of heat, temperature, pressure, and bacteria and algae, fungi, etc. takes place. That the polymers disposal takes place, disintegration takes place, degrade takes place. That type of polymers are called as biodegradable polymers. So these biodegradable polymers are mainly classified into two types. So one is the naturally occurring biodegradable polymers. Number two, synthetic biodegradable polymers. A plastic that undergoes degradation by biological process during the composting to yield carbon dioxide and water, inorganic compounds and biomass at rate of consistent of other compostable materials, and leaves no visible, distinguishable or toxic residue are called as compostable plastics. So just you see surgical and medicinal applications, that masks are there, gloves are there, or medicinal application, medicinal device are there, that all are maximum that stitches are there, or some screws, rods, nuts we are inserting in the operation time, so that are easily disposable. After 6 or 10 2 years, the disposal takes place. So like that, polymers are called as biodegradable polymers. The biodegradable polymers may be naturally occurring or may be synthesized by chemical means. That means by the action of biological action or chemical action takes place, then we are getting the synthesized biodegradable polymers. The biodegradable polymers are mainly classified into two types, that are naturally occurring biodegradable polymers. Next one, synthesized biodegradable polymers. So these naturally occurring biodegradable polymers, a wide variety of naturally occurring polymers are available. The fact that these substances were polymers was not known. In many quarters, this ignorance persists. The natural biodegradable polymers are classified into further four groups. So that are the naturally occurring biodegradable polymers are classified into again four types. What are they? So they are: number one, polysaccharides; number two, proteins; number three, polyesters; number three, others. So number one, that is polysaccharides, proteins, polyesters, last one is the others. So these naturally occurring biodegradable polymers are classified into four types: polysaccharides, proteins, polyesters, and others. So what are the polysaccharides? These polysaccharides are the starch and cellulose. Proteins are the wood, silk, gelatin, etc. Polyesters are the polyesters are polyhydroxy.
మేడం ఇప్పుడు మీరు ఫ్యాకల్టీ ఇచ్చారు కదా ఫస్ట్ ఇయర్ కి
Alkanides.
వాళ్ళ ఫైల్స్ కావాలి మేము అప్లోడ్ చేయాలా
Others are the lignite.
దాంట్లో జేసీలో ఇప్పుడు వాళ్ళ డేటా కావాలి కదా, ఇప్పుడు వాళ్ళు ఎప్పుడు హైయెస్ట్ డిగ్రీ క్వాలిఫికేషన్ అవన్నీ వాళ్ళ రిలీవింగ్ డేట్స్ అవన్నీ అది ఆ ఫైల్
Okay, na? So these are the naturally occurring biodegradable polymers. So polysaccharides, proteins, polyesters, and others. Next, coming to synthetically biodegradable polymers. So the synthesized biodegradable polymers are the polylactic acid, polyvinyl estates, polyesters, polyvinyl alcohols, polyamides, etc. These are prepared by synthetically only. That means by the chemical process or biological process, we have prepared the biodegradable polymers. Like that, polymers are called as synthesized biodegradable polymers. So these polylactic acids, polylactides, polyvinyl estates, polyvinyl alcohols, polyesters, polyamide esters, these all are the synthesized polymers. Then coming to our syllabus, in the syllabus, what are the synthesized biodegradable polymers? So in the current our syllabus, we have only two synthesized biodegradable polymers are there. Number one, polyvinyl acetate. Number two, polylactic acid. Polylactic acid. So this polyvinyl acetate is called as PVAC and polylactic acid is called as PLA. So these synthesized biodegradable polymers are polyvinyl acetate and next one is the polylactic acid. So how to prepare the polyvinyl acetate and how to prepare the polylactic acid? What are the properties and what are the applications of polylactic acid, polyvinyl acid? We'll discuss one by one. So synthesized biodegradable polymers are, example for that one is polylactic acid, polyvinyl estates, polyamides, polyamide esters, polyvinyl alcohols, etc. Among this one, we'll discuss about the kind of syllabus only. We have two are there, polyvinyl acetate and polylactic acid. So how to prepare the polyvinyl acetate and how to prepare the polylactic acid? Let's discuss one by one. So this poly next one is the poly polyvinyl acetate, that is PVAC, polyvinyl acetate. So this polyvinyl acetate is prepared by vinyl acetate. The structure of vinyl acetate is H2C double bond CH O C double bond O CH. So this is the called as vinyl acetate. So vinyl acetate undergo polymerization, undergo free radical, vinyl polymerization, free radical vinyl polymerization, that we are getting the polyvinyl acetate. H2C CH C double bond O CH taken. This is enzymes. So this is the polyvinyl acetate. This is the preparation of polyvinyl acetate. Polyvinyl acetate, how to prepare polyvinyl acetate? Polyvinyl acetate is prepared from vinyl acetate undergo free radical vinyl polymerization. Then we are getting the polyvinyl acetate. So this polyvinyl acetate are polyvinyl alcohols. PVA means polyvinyl alcohol. PVAC means polyvinyl acetate. Are rubbery synthetic polymers, which the formula is C4H64. The general formula for that one is the general formula of this polyesters, polyvinyl acetate of polyesters are RC double bond OO CH2. So this is called a general formula for esters family. If should not be confused with the related polyvinyl alcohol with its called as, so polyvinyl alcohol, that is called as PVA. Polyvinyl acetates means PVAC. The degree of polymerization of polyvinyl acetates are there that are 100 to 5,000. 100 to 5,000 times of degree of polymerizations are there. Degree of polymerization means number of monomer units are repeating linkage. So this polyvinyl acetate having the branch structure. This is a thermoplastic having resistance to sunlight properties, resistance to sunlight, moisture, acid, alkali, etc. These are all the properties about the polyvinyl acetate. So these polyvinyl acetates are mainly we are using adhesives and also medicinal applications and making of chewing gums, etc. So all of you, once you observe the preparation of polyvinyl acetate, all of you write down. Otherwise, all of you write down the preparation. Just a minute, make it fast, all of you. This is a preparation of polyvinyl acetate. Vinyl acetate undergo polymerization that form as a polyvinyl acetate. Preparation is very important for you. The applications of polyvinyl acetate is an emulsion in water. A PVAC, polyvinyl acetate emulsions are used for adhesives for porous materials, particularly for the wood, paper, and cloth, and as a consolidant for the porous building stones in a particular sandstones. The wood glue like PVC, polyvinyl acetates are also known as white glue and yellow carpentry glue. The stiff homopolymer PVAC, but mostly the more soft copolymer, a combination of vinyl acetates and ethylene. Vinyl acetate ethylene is used for making a paper coating, paint, and other industrial coating as binder in non-wovens, in glass fibers, sanitary napkins, filter papers, and in the textile finishing. So these polyvinyl acetates are mainly we are using adhesives, and also when these polyvinyl acetates are reaction with the ethylene molecule, vinyl acetates are reaction with ethylene molecule. Vinyl acetate is in molecular formation takes place. These are mainly we are used for paper coating and paint and other industries. Binder, non-wovens in glass fibers, sanitary napkins, filter papers in textile industries. That uses PVC can also be used as a coating to the protect cheese for fungi and humidity. Polyvinyl acetate also the raw material to make other polymers like polyvinyl alcohols. So vinyl acetate is prepared by ethylene molecule and reaction with oxygen and acetic acid in presence of palladium catalyst. We are getting the vinyl acetate. This vinyl acetate undergo free radical vinyl polymerization. Then we are getting the PVAC. That means PVAC stands for polyvinyl acetate. So the structure of that one is see observe. CH C double bond O. OC double bond OCH. So here double bonds are there. Here this will undergo free radical mechanism. That means undergo polymerization. That we are getting H2CCH taken n times O C double bond O CH. This is called a PVAC, polyvinyl acetate. So these are some mainly we are using in chewing gums and surgical operations, etc. Applications, properties about the polyvinyl acetate. Next one, polylactide. So polylactic acid and polylactide. Before we discussing about the polylactic acid and polylactide, so what are the applications? So these polylactic acid and polylactides are mainly we are using surgical operations like making of surgical items like mask, stitches, or pins, or rods, etc. We are used by using this one. We are prepared, and this will be disposal after 6 months to 2 years. So these the polylactic acid is a thermoplastic aliphatic polyester derived from new renewable resources and such as cornstarch, tobacco roots, chips or starch. The carboxylic acid and alcohol in groups are thus concentrated in the amorphous region of the solid polymer. So they can react to forms the polylactic acid. So this structure, the polylactic, how to prepare the polylactic acid, I will show here. So lactic acid, anyone know about lactic acid? So lactic acid, how to prepare lactic acid? Lactic acid is the chiral compound. Lactic acid is the chiral compound. So this has very distinctive properties. H3COH, H, C double bond O, OH. So this is the lactic acid. So this lactic acid that form as a ring structure. Double bond CH3. This is the lactate. This is the hello. So lactate formation. This lactate undergo polymerization. That we are getting the polylactic acid. That is
తర్వాత అన్నాడు ఫస్ట్ సిఎస్ ఎంటర్ చేస్తున్నాడు కొంచెం ప్రకాష్ రెడ్డి గారు కూర్చొచ్చిందా
ఆయన కూర్చుంటాడు. See what?
మా పూర్వలాగా ఉన్నాడు.
So this is a poly lactic acid or polylactide. Polylactic acid or polylactide. So polylactic acid is the chiral compound. This having the some distinct properties. Why? Because so you see in the lactic acid, in this carbon having the 4 different groups. So that is one is the CH3 group, one is the OH group, another 1, 2, 3, and 4 group. So 4 different groups are attached to the carbon. So this is called as chiral carbon. So that's why this lactic acid having some distinct properties. So when lactic acid forms as a lactide, this lactide undergo free radical polymerization, then we are getting the polylactic acid or polylactide formation takes place. So this polylactide having the some special properties, that is resistance to sunlight, moisture, acid, alkali, and good transitional temperature, and having melting points up to 172, 173 to 180 degrees centigrade temperature, having withstand high temperatures. So that is approximately 110 degrees centigrade temperature withstands. Okay. And these applications about the biodegradable polymers are mainly we are using medicinal applications and also making of chewing gums, like switches and pins, rods, etc. By using this one, we have prepared that all substances. Where we are used that one, we are used in the such medicinal applications. So this is about the preparation properties applications of polylactic acid or polylactide. In the examination point of view, they will give, write the properties, preparation properties applications of polylactic acid and polyvinyl estates. Okay. Rule number 69, Badam. Jayendra Reddy.
Yes, sir.
No,
No, sir.
are you fine?
Koncham cold headache undi, sir.
Once you read the properties of polylactic acid or polylactide, screen is sharing or not?
Undi, sir.
ఎక్కడున్నా ఇంట్లో ఉన్నావా ఎవరే బయట ఉన్నావా?
లేదు ఇంట్లోనే ఉన్నా సార్, వీడియో ఆన్ చేయాలా?
అదు సరే చదువు ఒకసారి. once you read the properties.
Due to the chiral nature of lactic acid.
Chiral. Due to the chiral nature of lactic acid.
Chiral
nature of lactic acid.
Several distinct forms of
polylactide.
Polylactide exist. Poly-L-lactide is the product resulting from polymerization of L-lactide, also known as L-lactide.
Okay. Next.
PLLA as
PLLA stands for poly-L-lactide.
Poly-L-lactide has a crystallinity of around 37%, a glass transition temperature between 60 to 65 degrees Celsius,
Okay.
a melting temperature between 173 to 178 degrees Celsius.
Okay. Okay. Hmm.
However, heat resistant PLA can withstand temperatures of 110 degrees Celsius. PLA is soluble in chlorinated solvents, hot benzene, tetrahydrofuran, and dioxide.
These are application properties about the, and except this one we have to write the resistance to sunlight, moisture, acid, alkali, UV light, oxidation, etc. These are the properties about the polylactic acid. Now applications. So these are mainly we are using example for disposable garments, and feminine hygiene products, that means diapers, etc. In that case we are using, and also this polylactic acid PLA also used for feedstock material in 3D printers. 3D printers we are use this one, and polylactic acid medicinal implants in the forms of screws, pins, rods, and as a measure depending on the exact type used, it breaks down within the body 6 to 2 years, that will be disposal takes place. So that's why these all polymers are called as biodegradable polymers. This is about polylactic acid applications, preparation, properties.
Hello, sir. Sir, మీరు కాలేజ్లో ఉన్నారు సార్? మీరు కాలేజ్లో ఉన్నారా సార్?
ఉన్నాను. ఎందుకు?
Sir, I have small issue regarding the college, sir. I want to talk with you.
You call me na?
నేను కాలేజ్ దగ్గర ఉన్నా సార్ కింద.
ఎక్కడ ఉన్నావు? ఇక్కడ STSP కి రా, 10008 రూమ్ రా.
అడ్మినిస్ట్రేటివ్ ఆఫీస్ దగ్గర ఉన్నా సార్.
అక్కడనే STSP
1008.
రా.
1008 సార్?
1008. రామ్.
3000
ఏంది?
6000 అందరూ ఎవరు వాళ్ళు అనుకున్నారు కాదండి.
గుర్తుంది ఓహో అదా
Likita,
ఏది
are you there?
వాడిది
Yes, sir.
Just please.
Okay. Any doubts or any clarification till now? Likita, absent is have written or shall I take attendance?
Yes, sir. I wrote it, sir.
All right.
66,
1 minute. 66.
68,
Hmm.
76,
Hmm.
88,
Hmm.
94,
Hmm.
95,
Hmm.
99,
Hmm.
B7,
Hmm.
C3.
See that. Any objection? So these are the absentees which read by Likita. Okay, thank you.
Yes, sir.